Ever pondered what makes lobsters unique in the vast sea of aquatic life? Today, we begin our journey into the intriguing world of these decapod crustaceans known as lobsters, who are renowned for their distinct anatomy and remarkable characteristics. Lobsters are undeniably fascinating creatures, boasting an intricate body structure that plays a crucial role in their survival and adaptability. From their resilient exoskeleton, mighty claws and agile legs to their responsive antennae and sharp eyes, every part of a lobster serves a unique purpose. Not only are these marine residents critical contributors to the ecological balance of our oceans, but they also hold a cherished place in the global culinary scene. Whether it's a decadent lobster bisque or a classic lobster thermidor, these crustaceans have become a gastronomic delight for many. So let's set sail on this captivating exploration. Stay tuned as we delve into the fascinating world of lobsters. One of the most notable features of a lobster is its hard, protective exoskeleton. This isn't just a mere shell, it's a complex structure that serves multiple functions, making the lobster a formidable creature of the sea. Let's dive in a little deeper. The exoskeleton is primarily made up of a substance called chitin, a tough, semi-transparent material that also makes up the cell walls of fungi and the hard shells of insects. This chitin is interlaced with a protein called sclerotin and hardened with calcium carbonate, the same material found in our own bones and teeth. This combination creates a robust shield that protects the lobster's soft inner body from predators and the harsh ocean environment. But the exoskeleton does more than just act as a suit of armor. It's also a support system, providing a framework for the lobster's muscles to attach to. Without a skeleton inside their bodies, like mammals, lobsters rely on this external skeletal system for movement and strength. Now, what's fascinating about this exoskeleton is that it doesn't grow with the lobster. This means that as a lobster gets bigger, it must shed or molt its old exoskeleton and form a new one. This process, known as ecdysis, can take several weeks. During this vulnerable time, the lobster hides away from predators until its new shell hardens. Molting also allows lobsters to regenerate lost limbs. Yes, you heard that right. If a lobster loses a claw or leg, it can grow a new one during its next molt. Talk about a creature with superpowers. This rigid exoskeleton sets lobsters apart from many other sea creatures, like fish and mammals, which either have internal skeletons or flexible bodies. It's a testament to the lobster's adaptability to its environment and survival over millions of years. The exoskeleton, a unique armor, is just the beginning of the lobster's fascinating anatomy. So, let's continue our exploration and see what other surprises this incredible creature has in store. Stay tuned! Look at a lobster and you can't miss its powerful claws and numerous legs. Lobsters boast an impressive set of claws, each serving a unique purpose. The larger of the claws, known as the crusher claw, lives up to its name. It's heavily built with strong muscles and a hard exoskeleton, enabling the lobster to crush its prey or defend itself from predators. Lobsters can exert tremendous pressure with this claw, comparable to several hundred pounds per square inch. The other claw, the cutter or Caesar claw, is smaller and sharper. It's designed for cutting and tearing food, allowing lobsters to enjoy a diverse diet, from fish and crabs to sea urchins and snails. Remarkably, lobsters can determine which claw will develop into the crusher or cutter while they're still in their larval stage. But the lobster's limbs don't stop at its claws. 10 slender legs support its body, allowing it to scuttle across the ocean floor. These legs are jointed, providing the flexibility needed for the lobster's sideways movement. Lobsters can also swim backward quickly by curling and uncurling their abdomen, but when it comes to walking, they prefer a leisurely pace. Here's a fun fact. Lobsters not only walk with their legs, but they also taste with them. Tiny sensory hairs cover the legs of a lobster, especially the smaller appendages near the mouth, known as maxillipeds. These hairs pick up chemical signals in the water, enabling the lobster to taste its food before it even reaches its mouth. Imagine being able to taste your dinner with your feet. So while lobsters might not win any beauty contests with their odd armored bodies and numerous limbs, there's no denying their fascinating adaptations. The powerful crusher claw, the precise cutter claw, the flexible legs, and the unique ability to taste with their appendages all contribute to the lobster's survival in diverse marine environments. From crushing prey to tasting food, the lobster's claws and legs serve multifaceted roles. Lobsters may not have ears, but they're far from deaf. This might be a bit surprising, but lobsters have a very unique way of sensing their environment. They rely heavily on two main sensory organs, their antennae and eyes. Starting with the antennae, these long, thin structures extending from the front of the lobster's head are not just for show. They're like the lobster's personal GPS, helping them navigate through the murky depths of the ocean. The antennae are covered in fine hairs that pick up on vibrations in the water, alerting the lobster to potential predators, prey, or changes in the current. It's like having a sixth sense, granting them the ability to feel what's happening around them without actually touching anything. The antennules, those smaller antennae-like structures near the base of the larger antennae, play a significant role as well. They're the lobster's chemical detectors, sniffing out food, mates, and danger. It's a fascinating adaptation that allows lobsters to thrive in environments where visibility is often limited. Now let's turn to the eyes. When you think of a lobster, you might picture those iconic bulging eyes on stalks. But there's much more to them than meets the eye. Lobster eyes are compound eyes made up of thousands of tiny lenses. These lenses allow the lobster to detect movement and changes in light intensity. However, they don't see clear images like we do. Instead, they perceive changes in their environment, helping them react quickly to potential threats or opportunities. While the lobster's vision is quite different from ours, it's perfectly adapted for their aquatic lifestyle. The compound eyes can work in extremely low light conditions, which is vital when you're living on the ocean floor. So, while lobsters may not hear in the conventional sense, they are far from being sensory deprived. They use their antennae and eyes in tandem, creating a powerful sensory system that helps them navigate the underwater world. With their antennae and eyes, lobsters can deftly navigate the depths of the ocean. Now, the lobster's tail isn't just for show, it's a powerful tool. Let's dive into the structure and function of this fascinating appendage and see how it contributes to the lobster's unique biology. The tail of a lobster, also known as the abdomen, is composed of 7 distinct segments. Each segment is encased in a hard exoskeleton, which provides protection and structure. On the underside of the tail, you'll find a series of small appendages called swimmerets. These swimmerets are not only used for swimming, but they also play a significant role in the lobster's reproductive process. And now let's talk about swimming. When a lobster needs to make a quick escape, it uses its tail to propel itself backwards through the water. This movement, called a tail flip, is lightning fast and can send the lobster shooting away from danger at impressive speeds. And while the tail is a formidable tool for mobility, it also houses the lobster's reproductive organs. Female lobsters carry their eggs on the underside of their tail, nestled safely among the swimmerets. These eggs are fertilized by the male and carried by the female until they're ready to hatch. During this time, the female lobster uses her swimmerets to keep the eggs clean and oxygenated. The tail is also where you'll find the lobster's telson and neuropods. These structures form the fan-like feature at the end of the tail, which is used to steer while swimming. The telson and neuropods work together like the rudder of a ship, helping the lobster navigate its underwater world with precision. So you see, the lobster's tail is far more than just a fancy appendage. It's a multifunctional tool, crucial for survival. It aids in swift escapes, enables precise navigation, and ensures the continuation of the lobster species. As we unravel the complexity of this creature, we find that every part of its anatomy has a specific and crucial role. The lobster's tail, a combination of strength and utility, completes our exploration of this creature's anatomy. So what makes a lobster a lobster? Well, it's a fascinating combination of their exoskeleton, claws, legs, antennae, eyes, tail, and abdomen, each contributing to their survival in unique ways. Starting with the exoskeleton, it not only provides a sturdy protective layer, but also allows for growth by molting. The claws and legs, each with a distinct role, serve as their primary tools for feeding and defense. The larger crusher claw is used for crushing prey, and the smaller cutter claw for tearing food apart. The antennae and eyes, on the other hand, play a crucial role in navigation and communication. The lobster's eyes can detect light and movement, while their antennae are sensitive to touch and taste. Lastly, the tail and abdomen, packed with muscular power, aid in rapid backward movement, an essential escape mechanism. Lobsters, with their unique anatomy and adaptations, truly are a marvel.